Welcome back to another video, and I know I haven't done one of these voiceovers in a little while, but I'm here today to talk about Homer's first launch and landing test and its flight profile and the cool and unique features that Homer will have. This is not an in-depth review of like Homer itself. That's coming after the launch. I'll see, when I could get that done. Um, but either way, let's get started. All right, so we are first gonna go over just some of the general stuff that goes along with Homer's flight profile, and this by no means is not an accurate diagram. I just drew it so you guys have a good visual of what some of the stuff is gonna look like. And just a disclaimer, I still fully do not know what I'm doing, like 100%. So a lot of the stuff I'm doing, um, may not be 100% correct or 100% accurate, but I just have this stuff in place for now. Just on the first flight test, or maybe if they work really well, then I'll keep them. But some of this stuff might not be 100% perfect, like super perfect or anything, because I'm not trying to aim for perfection here. I'm just trying to see if Homer can reliably land, because of a future goal I will discuss later. But for now, let's get started here, looking at Homer's ascent and descent profile. So first off here, there's nothing really. It's gonna be pretty typical with liftoff. You've seen it a lot with Odyssey. It's gonna look very similar. I might throw in a pitch over maneuver on the X and Y just to kind of avoid the smoke and everything for the landing shot. Um, but I'm not really too sure on that yet. I'll mention it in the description or in post-flight review video I do, if I did end up doing a pitch over maneuver. I might not, just to keep it simple, and not introduce any kind of failure points, but I don't know. We'll see. It's still kind of unsure, but anyway, so going up here, so it's burning through its ascent motor, and then the flight computer is looking for it's reading apogee, and this is gonna be the first time I'm actually reading apogee. Um, Odyssey tried to, never was able to, but Homer has a really nice altitude sensor, and I believe it's the SparkFun BMP 581, which someone in my Discord server recommended to me, and it's been working really good. So it was really nice choice for the altitude sensor. So basically, it's going to be looking for this number, the 15 meters. It's going to be looking for 15 meters or something along that altitude here. And what this is just to basically determine um, if it should start looking for not necessarily apogee. I know I just circled it, but it's going to start looking for if it's descending. So the way I find descent is basically if you're going down and then you figure out every time it reads, if it sees that we're going down for all these consecutive readings, it could basically assume that it's going down. So that's basically how we're finding descent in the first place. So when it passes this threshold, it's going to start looking for it. Now, that's going to probably be a little bit before burnout, maybe a little after. I don't know. I think 15 meters is probably a little bit before burnout, but anyway, it's going to start looking for that. And another actually thing to mention before I get too ahead of myself here is in this section of the flight, there is an abort mode that it is looking for, or like an abort violation. And Odyssey had the option to say it past 45 degrees, it had the option to pop the parachutes and basically terminate the flight. Homer does not have any parachutes on it. I didn't find the mass budget for it, and you know, if it lights the landing motor, then we do not need a parachute. But um, a more concerning thing is like if it starts going like crazy during flight, what do we do? Because it can't pop a parachute. The answer: nothing. I mean, Homer, at that point, you can't really do anything about it. But what it can do, the only thing it can do, is block the landing motor ignition. Um, so that's really the only abort stuff I'm going to have in here. Because even during descent, the best thing to do to abort is to actually light the landing motor, so you come down somewhat softly. Um, so it's going to be um, basically in this first, I guess, half of the motor burn, maybe a little later. it is going to basically be looking for that. Once we pass roughly 1.2 seconds into flight, it's going to basically be like, all right, we're fine, and not be concerned about aborting or anything. But yeah, I'm just gonna get that out of the way. It'll most likely never be triggered, but if it does, Homer will hit the ground, but not like the landing motor. But anyway, moving on. So after it passes this threshold, the flight computer's gonna be like, oh, we passed 15 meters, and it's gonna start looking, what I mentioned before, looking for consecutive descent readings. So I think it's set to, I think, 6 consecutive descent readings. I don't know. I might change it. I might not. But either way, after it reads descent 6 times, I have 6. So when it hits that 6-1, it goes up. We're going down, and then it switches states. So when it lifts off, it goes into the ascent state, and then when it starts going down, it's going to switch into the descent coast state. So there's only one descent state, but it's just named descent coast. So in descent coast, we're going to do a few critical things here. So I'm just going to use the 21.5 meter apogee here. This is what some of like the really basic simulators say, but I'm not, I have no data on it or anything. So probably around 20 meters or so, give or take. And this is if it goes perfectly straight up, which it's most likely not. So yeah, give or take 20 meters. So it's going to take this apogee and look for the landing burn start altitudes. Now, the way I'm doing this is super simple. It may not be the most accurate thing, but this is the most simple way. That's my motto, just trying to do things in the simplest way possible. So I'm not going to try to overcomplicate this. So it takes, I'm just going to use 20 meters here, and it multiplies it by, I think it's 58% of its apogee. So multiplies it by 0.58, and then this number then gets fed. Wait, let me remove this here real quick. So, and then this gets fed as the landing merge start, or I have the variable in the code LBS. So it basically sets LBS equal to whatever this is. And then that's basically now the altitude sensor is now looking for this number. So now it's going down, and I'll get to actually a key point during descent is it's going to be actively controlling its roll attitude. So I'll get to that later on. But that's another thing. It's going to activate the grid fins that are on the top, and also when it starts descending, it will also lock the motor mount. It will like reset the motor mount and everything. But yeah, so now it's descending, it's descending, it's descending, and now it hits the LBS. So when the altitude, I'm actually adding um I'm adding 1.2 meters, I think, or something around ish, 1 to 1.2 meters is. It's probably be like 1 meter. But it's going to add this to the LBS. And basically what that is just to give, you have the motor come up time from ignition command to actual thrust being produced. And I just want to give it time to build up thrust before actually hitting the landing merge start, because I basically sim this um, with a very basic ChatGPT written Arduino simulation for this, and I coded it or I set it to turn the motor on at a 11.2 Newton constant thrust, which is not how that works. Motors don't work like a light switch like that, so you can't just turn them on and off. So obviously there's a build-up time to thrust and everything, which I wasn't simulating. So this is just a, again, this is all just winging it here. So, you know, we're just trying to test new things and trying to see what works and what doesn't. That is really the key here. Um, but yeah, we're just trying to do this. If it lights it a little early, I don't care. I just want it to light the landing motor. That's the big one. I just do not want to light it too late. I mean, I'd be okay with that too. I just don't want to not light it at all. So I'd rather just light it a little high here. Even if it does, whatever. This is a development version of Homer anyway. I have a much better design in the works anyway. So, you know, whatever happens, happens on this flight. But yeah, that's just something I want to point out here too. But yeah, we light the landing motor and we try to keep Homer stable, and then we land. So I think that's pretty much it for the generic flight profile. Um, but without further ado, let's move in to the controlled descent phase. All right, so this is something that's very unique, I feel, to Homer and Homer's flight profile and everything, and what it's going to be doing in the future, and that is the grid fins. So these grid fins, the purpose for this version of Homer um, is to control the roll axis. So this is a top view where my cursor is. This is the top view of Homer. Um, so basically, the roll axis would be this way. So it basically rolling, which you don't really want to do when you're trying to land because it just kind of the TVC has to work like way harder because it's constantly rolling. But yeah, so I mean, on the way down, it's going to be controlling its roll attitude. I mean, actually, what I said before about TVC overworking, I mean, it just really depends. When the landing motor lights, the grid fins aren't actually really gonna. Actually, they'll actually shut off. So actually, disregard what I said about the first statement about the grid fins. But um, yeah, so basically, on its way down for the whole in between from apogee to landing motor start altitude it is going to be controlling the roll. Maybe I'll leave them on during the landing burn, I'm not sure. But this is an experimental thing. I've never done like aerodynamic control surfaces like this before, or like active aerodynamic control surfaces. Here's a bigger picture of the grid fin here. Um, but yeah. Yeah, so these ones have a bigger basically let me move over here to this model. They have a bigger square than the ones that are gonna fly on the future version of Homer. And let me as I say that now, why is testing this so important? Like what is the purpose of this? Um, other than just controlling the roll axis. The greater point of doing the grid fins and stuff like this, like now, is because final goal, I guess, for Homer is to land it in a net down range. And to do that, I'm going to be using these grid fins. There'll be four of them, not two, but there'll be four of them, two for each axis, and they will basically be guiding Homer from apogee to a net where Homer will land in it. So I know it's kind of crazy, um, but that's why I just want to kind of start kind of experimenting with grid fins now. So then when Homer's has to go try to land in the net, it will maybe be a little easier because I have some experience with them. Um, but yeah, so what I was saying before about the grid is these squares are much bigger um, than the ones that will be on the net landing version of Homer. The net landing version of Homer, they're going to be like maybe they'll be like way tighter and there'll be more of them. Just then it produces more aerodynamic drag. So actually, before I get too ahead of myself, how grid fins work is basically if we draw like a grid fin here and our airflow. Now I'm not too familiar with the direction of grid fins and the way they steer the air, but just bear with me. Um, so if they rotate this way, it will basically bend right here. So if we tip the grid fin this way, the air kind of hits it and goes off this way. Correct me if I'm wrong in the comments if I'm messing this up, because I'd actually really like to know. But anyway, let's just use this. So basically, when we're moving the grid fins like that, it basically moves the air, and when it moves the air, it creates roll torques, and it's pretty self-explanatory. As it's going down, it's just going to continue rotating the grid fin back and forth, or the two of them, to basically compensate for a roll error. So that's really what we're kind of doing here. So as it's going down, it will just steer the grid fins, and they'll move in opposite directions of each other. This down here is a bottom view, so this is the motor, and then these are the grid fins. This is kind of how far they stick out from the side of the rocket. But anyway, so that's really the basic of the Griffin. See, again, first flight test is we're just trying out all these new things that Homer has, and this is just a big one of them. But yeah, so as we steer the Griffin, we steer the air, resulting in roll torques or counter roll torques to basically keep Homer stable. But yeah, that is the guided descent portion of flight, and now we're going to move on to what I believe is why does Homer have no landing legs? Alrighty, so this is a very unique feature I think that Homer has. That a lot of other people that I've seen online do propulsive landing always have foldable landing legs that basically rotate out of the side of the rocket and lock out, so then it can land upright, like SpaceX's Falcon 9 and a bunch and some other ones. But this is not what I'm doing for Homer, which may seem kind of weird because it's like, all right, you're trying to do propulsive landing and you have no legs. Um, and that is a good point. So this was the first version of Homer I came up with, and you could clearly see it has landing legs. I fully intended for this version of Homer to have landing legs. These would be fixed in place. They're in these 3D printed mounts here. They're meant to just be fixed out. Um, and just they're just there to keep Homer upright when it lands. The problem came when I weighed the thing after I finished it. It was about 100 or so grams over target, and I don't know why. I think I lost mass tracking somewhere along the way, and I kind of just made the decision to scrap the legs entirely. It was a hard decision because I really wanted to see Homer land upright. But I just did not have the mass budget for Homer. This version of Homer was very challenging to do, just because like I designed things that were a little too heavy. I wasn't really keeping track of my mass budget too well, which is a common theme amongst most of my rockets, including Odyssey. That's why Odyssey only had 5 flights. It was supposed to have more, but its weight pretty much killed it. Um, so yeah, Homer had kind of the same problem. I've made good steps, and step one was removing these landing legs to basically lower the weight. So then we ended up with this. This is kind of the second iteration. I still wanted something to kind of protect the TVC mount, and this is the ascent motor here, but basically when it ejects that ascent motor, um, when it ejects the ascent motor, I don't want it landing on the motor mount, or at least I didn't at the time. I was kind of just like, if we could prevent it, then we should. Um, but yeah, I cut these legs up into little struts here that just kind of went below the TVC, so when it hit the ground, it didn't like hit the TVC really hard. Um, but then along a little later, I kind of was looking at these legs. I'm like, do I really need these? And they were kind of getting annoying because they overlap this little screw hole right there. So they were getting kind of annoying when I had to take out the motor mount a bunch. And I just kind of decided to just remove them entirely. So you might be thinking, well, why the heck are you removing the new legs too? You already removed the original landing legs, and now you're removing the new ones too. Now, the reason for that, partially mass, and partially because I just didn't really like them. They were kind of annoying. And also a key thing, which this is the number one reason why I took those legs off. During the second static fire test, the gimbal range on the TVC, which is the one that's on these two models of Homer, the gimbal range was way too small. Um, or at least that's what I thought. I think some new information that came out of Homer's third static fire test is kind of like half kind of proven that. But I don't think this was like all the fault, but basically I redesigned the motor mount to have like a crazy plus or minus 15-degree gimbal range, um, and on each axis mostly. And I think the X is more around plus or minus 12. But anyway, the point is, with that bigger gimbal range and the redesigned part of the motor mount, it literally couldn't fit with these legs. It was just blocking the TVC, and it would not have worked. So I tried my best, but these legs here just kept interfering with the TVC, and that was a huge no-no. So I just straight up removed them. And now Homer is just going to be landing on its motor mount. I suspect it's going to break every time. Well, it's a PLA printed mount. It's not anything crazy strong, and I do not care because I'm just going to be mass 3D printing these motor mounts. So I just have them on backup and everything. But that's going to be like the real key thing to this landing. And um, anyone who's watching this now knows that if it lands and it tips over, and it was technically a successful landing because it was designed to do that. Um, so yeah, although it was disappointing that, I didn't get to do a few leg landings, where it landed upright. Um, you know, it was just it's just that's how it is. And also another thing is the whole reason for the net landing, which I mentioned earlier, was to remove the legs. Like that was really the whole thing. It's like get rid of I think this was around 180 grams worth of hardware here just in the legs alone. And these were pretty thick carbon fiber rods and everything, so I could have just reduced the thickness of the carbon fiber and everything. But I was just like, you know what? And also they add complexity. You have to design a whole mechanism to have them fold out and everything. And that's just another thing that could go wrong. So for the net landing, it's again gonna launch up and then the net's gonna be here, and it's going to guide itself and land in the net. And the reason why it's landing in the net is the net basically acts as the landing pad, basically. And basically, the reason why it's a net, and the reason why I even came up with this idea in the first place, is because I was trying to figure out a way to catch a rocket, but not with a launch tower, because that's with the way I'm, designing Homer. Um, it's not, the way Homer's designed, it'd be practically really challenging and almost impossible probably at this scale to do something like that, with, like, the one motor and timing the landing motor and guiding it there and everything, so, um but yeah, with this setup, that was not practical, and I was just trying to figure out a way, that I could put a play on the words there, and, I caught the rocket in a net. That's pretty much what it's gonna be. So I just figured, well, if that's not gonna have landing legs, then why should this one? And then that was also on top of all the other issues I previous mentioned, like weight and interference with the TVC hardware, and and all this and all that other stuff that I mentioned. So that's really it. And I think this was like probably the most important section of the video, is just for you guys to understand that if you see it when it launches and it tips over on landing, that was intended. That was its intended purpose. I just want to hammer that home. It is not going to look like many of the other propulsive landings you may have seen online somewhere. So, and this is only going to be temporary. It's only going to be like 3 or 4 flights or so. Once Homer kind of gets locked in propulsive landing, and I think it's really good, and I'm really comfortable with it, then I'm going to go straight for the net. That's pretty much the plan. Um, but I mean, yeah, I think that's really it. And let's move on to the final thoughts. All right, guys. So here are my final thoughts on this launch here. Or this upcoming launch. Um, in general, I am very hyped about this flight test. We have some very unique things going on here that I haven't really seen anywhere else. I know a lot of people are hyped for this, and it's gonna be very interesting to see what happens. Again, I'm not doing anything in the most complicated ways or any of the really good ways of doing stuff or high accuracy. It's all just the simplest way possible. And I actually think that's a really good thing for a lot of you out there too. I know, people like me, if you're just starting, like, or when I just started, I really did not want to do, and I'm pretty much like mostly self-taught in, a lot of the hardware stuff. A lot of the software stuff I had a lot of people help me out with, but I've been pretty much learning things myself and trying to figure things out myself. Um, but again, highlight software, not so much. But um, a lot of people had to help me out with the software and different things. Um, but yeah, I think a majority of it was me trying to figure out myself, and I knew it was really hard when I was trying to try to figure out the most complicated ways of doing it, the most accurate ways of doing things. Trying to do things in the simplest way is my motto, and although they may not be the most accurate or like the best way of doing something, um, if they work, they work. As long as they work with no like 50-50 working rate, as long as they work and they're fine, um, and they give me desirable results, then I'm going to be happy with it. And I think, with all the uncertainty of this flight test and everything, just wanted to highlight this. God has his hands on this rocket. Like this, like, when it lights that landing motor, I mean, during the whole thing, I have no control over it. I could code it to the best of my ability and everything, but I'm very excited to see what God has in store for me with this rocket here. He's led me on this incredible journey through all of my rocketry 2.5 years, and this launch is going to be a real interesting one. I'll just tell you that. But yeah, he's got his hand on it, and we'll just see what happens. I think that's really the the fun part here. Just learn something new and yeah, to close out here, if you want to join my Discord server, you can. I would really appreciate it. I want to try to build up a community of people who are maybe trying to do this and need help, or just people that want to hang out and talk about this stuff. And I also just like having a bunch of people that could help me out and point out things if I'm doing something wrong or whatever. And same goes for anyone. If anyone needs help, and this is how I got started in this and in this whole thrust vector controlled journey here. But yeah, if any of you guys are starting and need help, join my server. I have a bunch of people in there that would most likely be gladly to help. Um, but yeah, if you want to just come hang out, talk about this stuff, whatever, I post some exclusive stuff on there sometimes, not always, um, but yeah, that being said, I'll see you after the flight.